Okay, today we're going to look at light rather than sound. So light is a different type of wave. It's a transverse wave. We're going to try and understand the words on the left, and we're going to make sure we have this idea that light is something that travels in a straight line. The first question we want to look at is this: can we see in the dark, and can any animal see in the dark? Now, the answer to that is actually no. Even animals that seem to be able to get around when it's very dark will still need a little bit of light in order to be able to see. If you're interested, the YouTube clip will tell you a lot more. So this is our title today, Light Waves and How Light Waves Travel. And we're going to understand the difference between luminous and non-luminous objects and describe how those light waves are going to travel. So your first task is to look at the difference between luminous and non-luminous objects. Now, a luminous object is one that actually produces its own light. So can you have a go at putting those into the correct spaces? These are the correct answers. Obviously, the computer screen has to be on in order to be able to be luminous. Any object that doesn't make its own light is called non-luminous. So your next task is to match up these words to the meaning. So pause the video and have a go. What you should find out is emit means gives out, so the sun emits a light. Reflect basically means bounces off a surface, so light is reflected from a mirror. Transmit means passes through, so light is passing through the air. Transparent is when light can pass through an object, so a window is transparent. Translucent means it can pass through a bit. Tracing paper would be translucent. And opaque means that the light can't travel through at all. So a brick is usually opaque. Absorb means taken in. So if there are any of those words you're not sure about, I'd like you to have a go at the activities on the BBC Bite Size. Our next task is to look at how light travels in straight lines. So here is a question. Here's a ray box producing light, and it's going to a tube, a bendy, opaque tube. That means opaque means that the light can't pass through the sides. How would you end up with a dot of light at the other end? So the answer is you'd have to straighten the tube because light travels in straight lines. Here we have another example. These are holes in the card, and we want to be able to see a dot of white light onto the card behind. What would we need to do? And the answer is we need to move the cards so that the holes line up. And again, this proves that light travels in straight lines. Shadows are also caused because the light travels in straight lines. The light rays can pass through the air, but they are absorbed by the material and therefore can't pass through. And that's why you get the outline of a shape. You can also see shadows depend on where the sun is. So in this diagram we have a tree, and Matilda is sitting in the park and she's looking at the shadow of a tall tree. Where will she see the shadow? Now you should get the idea that she should see it over at C, because the light rays can't pass through the tree, but they can pass through the air. And so the tree's leaves absorb the light, and we'll get the shadow at C. We can see lots of examples where light is travelling in straight lines when we see rays of light. So in these two diagrams, and we can also see spotlights. Again, they're caused because the light is travelling in straight lines. I also want you to answer this exam question. If you want to do the extension, I've got two choices for you today. You can either make a shadow puppet, try and think about how they work and how you could change the size of the puppet to make it bigger or smaller. Or you can have a go at making a sundial, and the link will show you links and to the resources to make one. I'd like to see both of those if you have a go.